So let's so for 3. So this is like a similar question to what we did on the that package I gave you yesterday, right? So all this question is asked to describe the transformations applied to the graph of y equals x squared, right? So if we pretended that the 5 wasn't there, I would have my base graph back, right? The y equals x squared, which we know what it looks like, right? But with the 5 there, it's implying something. This was like we called this q, right? So if I went y equals x squared plus q, where q was the vertical movement, right, of the graph. So in this instance, for A, you're going to say something like, okay, well, the graph y equals x squared has been vertically, this is like terminology you kind of want to use, vertically translated up 5 units, right? So we're going to take the base graph, and every point on it is going to get moved up 5 units, okay? That's what that means. Now, the tricky one, remember yesterday we talked about the 4 different things that we're talking about. So I'll write the question here and then we'll go talk about it. So y equals x minus 3 squared, right? That looks different than A. It looks different for a reason, right? Because if I wrote it like this, that means something different than the other one, right? Now this is a Q, right? So I'm going to take the base graph, I'm going to move it down 3. That's not what we're doing here, right? This question is saying, okay, well, it's the negative 3 is on the inside, right? And this always has like an opposite. Anything on the inside behaves in the opposite manner. Right? For instance, I might think, first of all, anything on the inside is horizontal, right? Right? Anything on the inside is horizontal. So you tell me if that's going left or right. Actually, Nancy wants to see if the pen's off. So anything on the inside is horizontal, right? And then the other part you got to look at is what's the sign, right? So I might intuitively think that it's on the inside of the bracket, so I know it's left or right. But now I'm like, okay, it's negative, so I'm going to go left, which isn't the case, right? It's opposite. Anything on the inside behaves opposite. That's kind of the rule, right? That's what we just said. So in this question, instead of saying, okay, it's going to go left, we're going to say, okay, well, it's horizontally translated. It's very similar in language. Horizontally translated to the right, and that's what's important, right? Right 3 units. Okay. Okay, and then what I'll do is I'll jump down. We'll look at, let me just go up here for a sec. Everybody good? We got all that copied down. So if I go up here, you would have seen this is the kind of, this is a parabola written in vertex form. And from vertex form, we got 3 transformations with a 4th added on, right? So you could see here yesterday, Okay, this is the base graph, y equals x squared, and then I start applying transformations, right? So the negative implies that things have been reflected. The 2, or the a value, implies vertical stretch or compression. And then anything on the inside we just did, that would be left 2, and this would be down 1. So the goal for today, or in the next few days, is that you guys are able to look at an equation like this and say, okay, I have my base graph, and then I'm going to do all of these things to it and produce a new one. That's the goal. Okay, so I'll do one down here. I'll do one of the more complicated ones from 7. Okay, like 7. I'll do 7e. I'll list all the transformations, and then I'll jump down and do maybe I'll do 8d. Okay, on a graph. Okay, and then you guys could work away for, I don't know, however much time. Okay, so I'll jump down to what did I say, 7e? So 7e looks like y equals negative 2x minus 4 squared plus 16, right? So on a test, I could ask you to do both. I could say, list me the transformations and then actually produce the graph. Okay, those would be the two things I could ask you to do. So then the negative out front implies that we're going to reflect the graph vertically, or you could say in the x-axis, right? That's from the negative, so I'll color code this, and this is basically like if you go watch the other video that I have up there, right? The other video kind of color codes everything too, right? And I'll just do this, so I think it's nice. Okay, the next thing is the 2. What does the 2 control? Right? Well, the terminology around the 2 is that we're going to take all the y values and they're going to be multiplied by 2. So we saw like what happened when we plugged in x values or we inputted things and then got outputs. The graph got taller and skinnier. So that physically meant that I grabbed on the top of the graph and I pulled by a factor of 2. So I vertically stretched it. That's the terminology, right? So I'm going to say vertically stretched by a factor of 2. Okay. Then the next thing, so that you're halfway now, right? The next thing is going to be this piece here, the h value, so horizontal, right? That we are saying as like what we did up top, right? So it's like horizontally translated right 4 units, right? And then the last one is the easy one. That's Q, right? Q we know as being the vertical piece, right? So we're going to say vertically um, 16 units up. Okay, so you can see each of the 4 pieces there, right? If the negative's not there, then you only have 3 pieces, right? If the 2 is not there and it's just a 1, then you're just moving the graph left and right and up and down, right? You can see how like I can make, that's probably as complicated as I can make it, and it's as complicated as you're going to see anyway. In some of the 3U, you might have seen like we would have done reflections in the x-axis as well, or sorry, the y-axis, so horizontal reflections, and then we could have also stretched the graph horizontally, which we're not going to do, right? We're just going to do, we're just moving the parabola around. This is like grade 10 academic, right? And that's kind of the end point for you. Okay, so that's probably as hard as it's going to get. Okay? just keeping track of each of these. So when you go to watch the video, and I'll show you how to do this in a sec, but much like anything else, when you do this stuff, you're gonna it's like a book, right? So I'm gonna read the transformations from left to right. Then I don't mess them up. You can't do them in any order that you want because it kind of makes the reflection makes things a little bit tricky, right? So just to be safe, I always just start at the left and then I read right. So I would do the reflection, then I would multiply by 2, then I would move to the right 4, and then I would move the graph up 16. Just like a book, left to right. Okay. If some of you do go on to take the 3U, that becomes a common, it's a better practice because some things start happening when you stretch things horizontally or reflect horizontally, like some odd things start happening. So if you just follow it from left to right, you don't mess it up. Okay. So if we go down now, I'll go down to, what did I say I was going to do? 8D. Okay, I'll go down to the grid paper. I'll do 8D here. Okay. So 8D says, okay, here's the equation for 8D. Y equals 1/2 x plus 4 squared minus 5. Okay. So I don't see any reflection, so that's kind of nice. But what's my starting point? Oh, no. Yeah. No, we haven't done that yet. So we'll get to that. That'll be kind of the next stage after this. After we do the transformations and everything, that's my next gateway to what we're doing, right? What I'm saying is like the base graph. I want to draw the base graph in, I'll draw the base graph like always, y equals x squared in black, okay? So y equals x squared looks like this, 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4, right? That's the base parabola, y equals x squared, that's black, okay? Now, here's how I like doing this. This is how I did this in high school. I figured it out, right? So I take, if this one's in black, I'm going to do the first transformation in, I'm going to take care of the 1/2 first. Okay, and I'm going to do it in orange. Okay. So the first transformation is telling me to vertically compress the graph by a factor of 1/2, which essentially means I'm going to take all their y values and I'm going to cut them in half, right? So here, this point here is at 4, so I'm going to cut it in half and go to 2. Okay? And then the 1 goes to 0.5, 0 stays at 0, and then it stays the same on the other side. It goes back. Okay, so essentially what's happened is the graph has been pushed down and made look wider, right? Because of the half. And then the next thing I would do is be, okay, well, I'm going to do the next transformation I see. Well, the next transformation I see is the plus 4. The 4's on the inside, so I know it has to be opposite, right? So I'm going to take it, and I'm going to move it to the left 4. Every point I take, it's going to go left 4. So here's this. 1, 2, 3, 4. Take the next point. 1, 2, 3, 4. Take this one. 1, 2, 3, 4. And then I take these two. Is that it? Oh, sorry, there's halves in there too. Okay. So that's me move the graph to the left now. And then I only have one more transformation to do. It's to move it up by 5. Okay. So let's do that one in green. Okay. So I'm going to take each of those points now and move them up 5. And that's it. That'll be the final graph. Oh, it is down 5, sorry. It's down 5 because it's minus, sorry. That's supposed to be the easy one and I messed it up. Okay, so I'm going to take it and then move each of the points down. Right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. There's your final graph, right? So this whole thing's going to be in green now, right? That's your final product. And then you can check that. You can check it by typing it into the Desmos, and you can see if you're in the right ballpark, right? If you type it into Desmos and the graph's over here, right, then you moved it to the left where you should have moved it to the right. Yes, actually.
So you just kind of want to do it from left to right to make it easy for you.
It's like a book, right? You guys get the hang of this. I'll show you a different method that maybe you like more. I don't know. I'll show you both, just in case you do take the 3U or whatever. That was my next lesson for today, but we're kind of all over the place, right? So I don't know if you guys want to take some time and work on a couple of these, transform them. You got some grid paper, right? I like doing them in multiple colors. If you're confident enough, I think you could do the reflection and the vertical stretch together. So you could combine the two. And then you could do the left and right movements with the up and downs together, right? So you could start combining transformations as you get better at them. Just the risk with that is maybe if you go the wrong direction, like it's going to be wrong, right? So that's all I got, I think. That's it. Just left to right like a book.